Let's prove 2 is equal to 1. That sounds weird. Let's still do it. Weird is good. Okay. Let's say we have two numbers a and b that are equal positive numbers. Let's just assume that we have two numbers a and b that just happen to be equal. So a is equal to b, that's given to us. I can do a square is equal to ab. Keep going. 2 is equal to 1. Wonderful. Where did I make a mistake? I don't know. Where did I make a mistake? Okay, you find it out and let me know in class. Let's look at one more example. Use direct proof to show that sum of two odd number integers is even. Let n and m be two odd numbers. The fact that they're odd means that n is of the form 2k plus 1, m is of the form 2j plus 1. So if I do n plus m, I can write it as 2 times something that happens to be an integer, and that means n plus m is even. Use a direct proof to show that sum of two even integers is even. The proof is going to be very similar to what we did on the previous slide. N is of the form 2k, m is of the form 2j. If I do n plus m, it's going to be 2 times something, in this case k plus j. Let's look at one more example. Here we are given n as an integer, and we have to show that if n cube plus 5 is odd, then n is even. And we want to show this using direct method as well as indirect method and by proof by contradiction. So let's start with the direct method. N is an integer, n cube plus 5 is odd, and our goal is to show that n is even. So I have two premises. I can write them down first. Then what? Kind of stuck. I don't know what to do now. I don't know how to get from n cube plus 5 to n. Okay. So direct method kind of got stuck. Let's try the indirect method. So here we have the formula original was P implies C. We want to convert it to not C implies not P. Now that would mean the formula that I'm going to have is n is odd implies n cube plus 5 is even. First of all, verify that this contrapositive is exactly what we want. Now let's look at the proof. We have n is odd. That's a premise we have now because we changed what we're going to prove. This is my premise now. So n is of the form 2k plus 1. So you can do n cube. N cube would be this binomial expansion that I can do. 8k cube plus 12k square plus 6k plus 1. Now I can say that n cube is odd because I can write this as 2 times something plus 1. And now I can add plus 5. That will make it even. Proof by contradiction is going to be similar. It's essentially going to have one extra step, which is what we ended up with the last time was nq plus 5 is even. If we're assuming nq plus 5 is odd, which is our premise, that will lead to a contradiction. Once again, we are at the check before you go ahead slide. What I want you to do here is to be able to convert the proof that we had on the previous slide into a formal proof with existential universal quantifiers as needed. We have reached the end of the module, so go ahead and do the review quiz for this module as well.